Hello and welcome to Monday's edition of Cracking the Cryptic, and I've just read the rules of this puzzle that Mark has suggested I try today, and they are absolutely terrifying, as indeed are the comments on Logic Masters Germany, because when I saw I was doing this, I then read the rules, looked it up on Logic Masters Germany. I'm going to basically tell you that there is some maths going on in this grid, except it's by Chameleon, by the way. It's called Meanest Mini. And as far as I can gather from the rules, we aren't told what digits we're meant to use in this 6x6 Sudoku. So we've got to work out what digits we have to use, which is normally the case with Mean Mini puzzles. However, I think some of the digits that we have to use are not integers. Let that just sit in your mind for a moment. If you're anything like me, the amount of panic that will instill in you is quite dramatic. And look, these are some of the comments. So Samuel 1997 said, "The Sudoku part is very fun. The maths part is insane. I would be admired if someone could solve this puzzle without any note or calculator." Alfresco writes, "Crazy puzzle idea, check. Concept taken to the extreme, check. Very clever setting, check. Yes, it must be a Chameleon puzzle. Combination of Sudoku and algebra logic." Samu Piano, absolutely incredible puzzle, one of my all-time favourites. There was another comment though. Mixo, one of the weirdest and coolest puzzles I ever solved. Oh, this one. Yeah, this was the one. Difficulty greater than 5 stars if calculator is not allowed. What does the bookworm say? Yeah, this puzzle is unusual in that 90% of the deductions aren't really Sudoku. It's just doing a bunch of maths. Luckily, I really like maths, so I enjoyed this puzzle a lot. Yeah, so I have no idea what this means, but I'm terrified by the thought that I'm going to have to use. I don't even know how I'm going to put in non-integers into the grid. How am I going to do that? Maybe Chameleon actually is a setting, as a computer genius, and has sort of been responsible for many of the innovations in computer solving, along of course with Sven, with whom we work and who is responsible for Sudoku Pad that we use in the videos. But Chameleon often comes up with these rinky-dink additions, and so I'm just wondering, no, well, I don't see. Can I put 1.7 in? No, point doesn't work. I was just seeing if it would let me put in a non-integer, but it doesn't. So unless there's something in the settings. No, I don't think so. I don't understand how I'm meant to fill the puzzle in if it really has non-integers in it. Anyway, this is all for the future. We will work that out when we start solving this. Do I have any news for you? Brief news. We're streaming on Wednesday night. We're going to be trying a puzzle called Hexcells. Oh, doesn't go in the screen. There we go. Hexcells, which is like Minesweeper with hexagons. And it sounds very good fun, and we're looking forward to it. 10 o'clock UK time. We'd love to have your company. Over on Patreon, we've got a variety of things. We have Monster Solves by me, although one of the Monster Solves is going to make its way onto the main channel soon. Totally Normal Cats, Broken Secrets, a wonderful, wonderful puzzle. Very difficult, but my video of that is going to go onto the main channel probably later this week in a morning slot. But there's also, if you really, really like long videos, there's my 2.5 hour battle with the Cogito's roller coaster Nurikabe, to either entertain or, I don't know, send you to sleep or something. And of course, there's our Sudoku Hunt competition for January. All the fun of the fair, which lots of you have been enjoying. And then I've got 2 birthdays to do today. I'm going to start by wishing Patrick a very happy birthday. Patrick turns 22 today. I hope you've managed to organise some chocolate cake for yourself. And apparently you've barely missed a birthday announcement in the last year. Well, thank you very much, Patrick, for watching so many videos. We really do appreciate it. And many happy returns of the day. And then the next birthday, over there in Massachusetts, where I understand it is freezing cold at the moment, it's young Max's birthday. Max turns 9 today. And Max, I know this because your mum Sarah wrote to us and said that you've started watching some of the videos and getting into Sudoku, which apparently is because Roblox has a Sudoku game within it. And Max apparently has requested a cake which has a ratio of icing to cake that's even more extreme than I might advocate. Well, frankly, that is a fantastic thing to do, Max. I hope you get your perfect cake today. And your mum Sarah was kind enough. I think your mum Sarah is a high school chemistry teacher who would assign our videos extra credit, which is very kind. And Sarah, thank you for the kind words in your email. But Max, happy birthday, my friend. It is wonderful to hear when we have young viewers joining us. Now, let us turn our attention to Meanest Mini by Chameleon and see what Chameleon has in store for us. These are the rules. Mean Mini Sudoku. Place 6 distinct numbers, and numbers is in capital letters, from 1 to 9 in each row, column and box without repeats. Lines with circled cells and mathematical operators between them must contain a true mathematical equation. Yeah, okay, so that's what I was expecting. So those 4 numbers, you add them up and you get that number. These 2 numbers are multiplied together, those 2 numbers are added up, and they would give the same answer. So that makes sense. And then it says, the next paragraph, oh yeah, you probably already guessed it. But the numbers don't have to be integers. They must be real, though. Now, I vaguely remember from school, which was, a couple of years ago, that real numbers are those that are not the square root of -1. Is that right? Is I the square root of -1? So, I wouldn't have even thought about putting I in the puzzle. Why do I have to worry about that? That's completely ludicrous. Anyway, I don't know what to say. Do have a go. There's only 36 cells to fill. How hard can it be? The way to play is to click the link under the video as usual, but now I get to play. Let's get cracking. And while we're getting cracking, I don't know how I'm going to put numbers in if there are none integers. And why does it say I've probably already guessed that there... Why would I look at this grid and immediately assume there were none integers? I don't know. Numbers from 1 to 9. Numbers. Okay. Anyway, let's try and do... What are we going to do here? So, we can do... Well, we can't really do very much. I was still wondering if I could put 1 into box 6. I can't really. I don't think it can be the equals number, can it? No, actually it can't be the equals number. Because it does say that the numbers that we're selecting for the Sudoku are numbers from 1 to 9. So each of these numbers individually is either 1 or higher. So this number is at least 4. So it's definitely not equal to 1. Okay, so 1 is in one of those 2 squares. That's not the most massive deduction, is it? What on earth? Oh, I see. Oh no, I do see. I do see something. Okay, we've got to be careful to avoid iteration in the bottom 2 rows. Right, I see. Right, this digit, I don't know, let's make it blue. This digit, where does it go in this box? And the answer is, well, we know it's not the 1, so it's in one of those 2 squares. But then it's going to form this. It's going to form a sum equal to this number. So what would happen if this number, let's make this, I don't know, orange. If this is orange and was here, or here, in box 5, then the equations are just going to go round in a circle, aren't they? Well, there's definitely paradoxical, because we're saying that orange adds up. Orange is smaller than blue, and in this equation, blue is smaller than orange. So that can't be right. So that has to go there. There we go. There is an actual deduction. And okay, well this is already actually, it's already interesting, because we can't, this number can't be bigger, it can't be actually bigger than 9. It could be 9 and probably is 9, but it can't be bigger than 9. But this number is at least equal to, well, that's the interesting question as well. Because we are given two numbers in the grid. We're given a 1 and a 2. That can't be a 2. No, I mean, it so obviously can't be a 2. But I mean, I'm sorry, I'm just trying to get to grips with the puzzle here. But it can't be a 2. It's adding 4 numbers that are at least 1. But we know one of those numbers is at least 4. So this number is quite a big number. So 2 in this row, it can't be the solution to 4 numbers that are at least 1 being added up. So 2, well, 2 is in one of those squares. I don't really know how to pencil mark that, but that means that this number is now equal to 2 plus 1 plus 2 other numbers that are at least 1. Or actually, they've got to be bigger than 1 technically, but we're told they might not be integers. So this number is now at least 5. Well, no, it's not able to equal 5, because 2 of these numbers that are not 2 and 1 have to be bigger than 1, because otherwise 1 would repeat in the row, because there is a 1 here. Let's give this 1 a colour. We'll make it purple. So it's a purple in one of those. One of these is a 2. I will pencil mark that, although it's a dreadful pencil mark across boxes. And this digit now, one of these digits is at least 5, but it's 5, at least 5.0000000001, if you see what I mean, because 2 of these have to be greater than 1, and they're contributing to the sum of this one. So this number, which has to be no greater than 9 itself, is potentially 5 and a scintilla. Oh, what's the mathematical term for a scintilla? Like, you know, if you differentiate something, you're moving it on by a sort of... Oh, gosh, I used to be all over that stuff when I was young. I don't know. I can't remember. That's depressing. So, but anyway, this is 5 and a scintilla plus 1. That is 6. Plus 2 more digits that are at least equal to 1. Ah, I've got a digit. I've got 2 more digits, I think. Oh, this is wonderful. Sorry, let me just check this. 5 plus 1 is 6. Yeah, I have got a digit. Okay, where is 2 in the bottom row? Now, I might be wrong about this, so forgive me if I am wrong. But if I do put 2 in this equation, isn't this bigger than 9 now? I think it is, because this is 5 and a scintilla in one of these. So if I add 1 and 2 to that, we've got 8 and a scintilla plus this digit, or this digit, whichever one of these is not the 5 number. And that number is going to be slightly greater than 1 at the very least. And that means this number is more than 9, so you can't put 2 in the equation down here, which means that's a 2 in the corner. And now neither of these are 2. I lose my rancid pencil mark, and I get to put a 2 here. And therefore there's a 2 in one of these squares. Ooh, look at this. There's a 2 up here on a multiplication sign. Oh, I already like this very much. But here is another thought about this equation down here, because I think it's got to have some very strange numbers in it. Because we've got 5 and a scintilla at minimum, plus 1, that's 6 and a scintilla. Yeah, well, the corollary, I suppose, of not being able to put a 2 into this equation is that the 2 digits that are not 5 and a scintilla in this row... Oh, just had another thought, but I'll come back to that. The two digits in this equation that are not the blue digit and are not this digit have to add up. Well, that each individually has to be lower than 2. So this is why you need non-integers. Now, how was I meant to see that from just the start of the puzzle? Oh yeah, you probably already guessed it, but the numbers don't have to be integers. Do people just notice things like that? Well, they probably do, I suppose, but I didn't. Okay, so how do we pencil? So this has to be a number that is between 1 and 2. We'll put 1 in there. A little 1 means a digit that is slightly greater than 1. So we've got slightly greater than 5. Then add that in, slightly greater than 6. Add that in, slightly greater than 7. Add one of these, which is slightly greater than 1, so that's slightly greater than 8. So this one is slightly greater than 8 and less than 9. Or it could be 9, couldn't it? It could be exactly 9. Let me just read the rules again. Yeah, so this is between 8 and 9. But I think it could equal 9, and I'm sort of tempted to say it's going to equal 9. If these were, they have to be distinct, don't they? So if one of these was 1.75 and the other was 1.25, how does that work? Oh no, hang on, I've got a problem here. I've still got a problem, haven't I? Because this, I'm adding on at least 3 and a scintilla to this number. So this number can't be 6 now. This has to be no greater than 5.9999999. Because if this is 6, the 3 numbers here that are either the integer 1 and the 2 numbers that we know are 1 and some decimal will add up to 3 and some decimal. So this can't be 6 because that would be greater than 9. Yeah, okay. So this is a little... Well, these digits are the same, aren't they? Yeah, that must be right, by Sudoku. So these digits are a number that's slightly bigger than 1. One of these is an actual integer 1, and one of these is some naughty variant that's slightly greater than 1. So these add up to 5 and a decimal number. This is 5 point something, but it must be less than 6. And then we've got 5 point something plus 3 point something to equal 8 point something that's in this square. But this could still be 9. Wow. Okay. Maybe I have to give... Maybe I'll give the 2s a colour as well. So I should give... I'm thinking this must be a colouring puzzle, mustn't it? So I'm going to give those... I give these a colour, and one of these, therefore, is the green number. And the green number... In fact, well, both of these squares have a number that begins with 1 in them. One of them is a 1, and one of them is a 1 point something number. And but these numbers are not the same. These numbers are not the same. They are... One of them is 5 point something that can't be as high as 6, and the other is a 1 point something that goes in there. Okay, all right, sorry. Now, getting distracted trying to understand what the restrictions are at the bottom of the grid, but let's have a think about the top of the grid now, and especially that must be where we go now, isn't it? So we know that the panoply of digits that we're dealing with are lots of digits that are around the value of 1, and a massive number, which is an 8 or a 9, but no greater than 9. But, okay. Okay, but this multiplier, I can't remember what the correct product, this product is the sum of 2 of the Sudoku numbers. So if we put the 8 number in here, that's too big, isn't it? Because that's going to be at least 16, and we'd have to not have the 8 number in here. And the highest number we've got is a 5 plus a 2. So this is the highest value. Oh, no, we can't even use the 2. So it'd be 5 plus a 1 point something number. 5 point something plus 1 point something. So this is no greater than it can't even equal 7. And so definitely not. There is no 8 number in here. Oh, okay. Let's put the 8 number's probably there on that side of the equation, isn't it? I was wondering if I could get the 8 number in box 1. No, that's not even true. The 8 number's in one of 3 places. Okay, let's have a think about... Well, it feels to me like the way this is going to work then is we're going to have the 8 number here and the 5 number here, because that's going to be a number that's slightly greater than 10 and maxed out. It's going to be slightly less than 12. Oh, actually, that's quite hard, isn't it? So if this was 8 point something, can you make that work? That doesn't feel like it works at first blush, which is very surprising, because that's going to mean this is a very low total. Let me think about that. Sorry. So what I'm saying is, can that be 2 and then this 5 number? But that 5 number can't be as high as 6. So this is a number that is less than 12 but greater than 10. And this number, if it had the 8 in it, so if one of these is the 8, which it would have to be to get up this high, the other number can't be a 2, so it would be a 1 number. But can that get high enough? I suppose if it was 8 point, we said that could be 9, didn't we? This is what's going to do it. So if this isn't exactly 9, and then we add a 1 number that's not exactly 1 to that, we do get slightly over 10, which would work. But that's going to require this to be quite big. It's going to require the decimal portions of the 8 number and the 1 number that we add to the 8 number to be relatively meaningful. Because if it was 8.1 and we added that to 1.1, you'd only have 9.2 here, and we know we've got to beat a value of 10. Just trying to think about this, because the other thing we've got going on here is that this number is partly made up of this number. It contributes to the value of this number. So 2 lots of this number. I've got 2 lots of the decimal portions of the non-integer numbers in this equation. But then 8. Eight has got 8 in and of Wow. Okay. I've got something complicated. That actually means this is not 2 times 5, I think. Right, I'm just going to do... well, now I'm going to do this and try and articulate what I've just been going through in my brain. And we will see whether my brain is right or not. I think it's right. So what I was thinking is, if this has got 5, if this has got the blue number in it, how can we think about the decimal portion of this number now? And it's going to be 2 times all of these numbers. But 2 of these numbers, one of these numbers is a 2, which is a real 2. It's an integer 2. One of these is an integer 1, so they have no decimal component. 2 of these, we don't know which 2, although one of them is this one. Two of them are 1 point something numbers. So the decimal expression of this number is going to include 2 times whatever the decimal portion of this is, and 2 times whatever the decimal portion of the green digit is, because the green digit is a 1 point something number as well. So imagine this was 1.1 and the green digit was 1.2. Then we know that this would multiply by 2 is 1.2. This multiplied by 2 is, 2.2. This would be 2.4, but the decimal portions of each then would be, this would be a 0.6 number, because it would have 0.4 from here and 0.2 from here. So this would end in 0.6. But what would this side of the equation end in? Well, we know one of the digits in here is an 8, the 8 number. Now the 8 number, its constituent decimal parts are a blue number, which we know includes 1 decimal part from yellow and 1 decimal part from green. And if you look at this equation, it's got another yellow and another blue in it. Sorry, another green in it. So it's got another of the 1 point something numbers, and another of the 1 point something numbers in the form of green here. So the 8 number in and of itself also includes 2 lots of the decimal part of the 1 digit, the yellow digit, and 2 parts of the decimal part of the green digit. So at the moment, the decimal parts of the left and the decimal parts of the right are equal to one another. So what digit must we include with the 8 here to make this equation balance then? Well, it must be an integer. And this is what I just noticed, is you can't put an integer here with the 8. You can't put 2 in by Sudoku. And you might say, but we could put 1 in, and that's what I was thinking. That was going to be a 1. But then I realised that 1 plus 8 point something is not equal to 10. It's not enough. So it's wrong. This is wrong. And if it's wrong, that's going to be weird, because now this equation, which is 2 times something, well, the only numbers that we're allowed to use now all begin with a 1. Now, surely it can't be. It can't be 2 times 1 itself, whichever number 1 was. It can't be 2 times 1, this equaling 2, because then what Sudoku digits are we putting in here when each is at least now equal to 1 point something because we've used the 1? That's not going to work. So this is 2 times a 1 point something number. So this is like that, where one of these numbers is either the yellow number, it would be good if it was that one. We would know which one it was. And this side of right, got it. So this side of the equation now has to include numbers that add up to this. Now the 1 point something number here, well, one of these numbers, the only low digits we've got available now, given we can't use the 2, and we can't use one of the 1 point something numbers, and 5 and 8 are definitely too big to be in here, because the maximum that this can sum to is a number that's less than 4. If it was 1.999999999 times 2, it wouldn't quite get to 4, would it? So we can't include the 5 or the 8 here. So this definitely must include the integer 1, which must go there by Sudoku. And this number is the other one, which is the one, I don't know which one it is, but it's the 1 point something number that isn't the 1 point something number we've used in here. Right, so now we know in row 2, where does that digit go? And it's got to go there. So that's blue, and that's 5 point something, not as high as 6. And therefore that 8 could be as high as 9, which is orange. Oh, that's probably going to make that orange. Well, where is orange in here? We know it's not there, so it must be there. And, well, let's have a think. I've not thought about this equation at all yet. But what the question I was wondering about is, could we make this orange? So if that's an orange 8, if we can't make this even equal to 1. We could make this equal to 1 point something, and that would give us it would give us, I suppose, 8 and a decimal at the least here, plus maybe the digit 1 here, so 9 and a decimal, yeah, which is far too big for this number. So this is definitely not 8. So that's got to be 8 in box 3. Yeah, and that does prove that that's 8, look. Or 8, 9, or whatever it is in here. Okay. Oh, so I've got a 2-1 pair here. So this is purple. This is these 2 digits. That digit. Ah, hang on. The blue digit is looking down here. So this corner digit is not blue. This must be green, so that one's blue. So now you want to say that's got to be yellow, is that right? I think by Sudoku that's got to be right. Yellow must be in one of those in box 3. So yellow hasn't appeared in column 1 at all. So there's a 1 point something number here, which means that digit is the green digit by a process of elimination. So that digit is the green digit. We already know that. That's the 5 point something digit. So this has got yellow. Oh, look. This has got yellow in it, and I know where it goes. This is sensationally clever. This is now the 2 integer digit. This is not 2, has no part of 2 involved in it. Okay. Now, what next? So these 2 digits are the 5. These are blue and yellow by Sudoku. Yeah, we've sort of got a version of roping going on in this puzzle, because look, it always maps to the same domino going down the grid in a 6x6. That feels quite comic. Okay, I wanted to make those blue and yellow. That's what I was just saying. But that doesn't mean that we've got roping here, does it? Although we do have sideways roping there. But we're always going to have sideways roping in a 6x6, Simon. That is just a feature of them. So 2 is in one of these squares by Sudoku. Yellow is in one of those squares. I'm sorry, I can't quite see what to do now. I think we're going to have to look at this equation in a second or two. But I'm just trying to see if I can get some more Sudoku done to try and... These two digits are a 2-1 pair, although that's very hard to pencil mark, because 2 and 1 in the centre in a normal Sudoku would mean something very profound. In this Sudoku, they don't. In fact, I think I've got to not do that. I think I've got to put those in a corner, because wherever I've put 1 in the middle of a cell, I'm not saying it's the digit 1. I'm saying it's definitely not the digit 1. It's 1 and a decimal. And okay. Right, so what do we now know? Let's have a look at this equation and work out what's going on here. We have got an 8 number that could be as big as 9 is equal to a number that is an integer, that's a 1 or a 2, added to 2 numbers multiplied together. Now, okay, so this does have to be the blue number, doesn't it? Because if this wasn't the 5 number, if it was the yellow number, which is 1 point something, we'd have a 1 point something number times a 1 point something number, even if these were just as close as you could possibly get them to 2, so that this was as close as you could possibly get to 4, 2 times 2. Even if we added 2 to that, we'd only get to a maximum there of just a scintilla below 6, and that is definitely not equal to at least 8, which is what this is. So we've got to put the blue digit in this equation, and that means we get to put the 1 point something number here. So now we've got another equation. We've got the ability to place exactly yellow in row 3, which means I must know that digit, which, oh no, maybe I don't know that digit. That digit is red or purple. So that's an integer, which means I must do that in the square. And that's equal to that. I've got a bad feeling about this. This doesn't look like it's going to resolve. Hang on. In fact, that's a very reasonable question, I suddenly thought. I think I've broken the puzzle. Ah, I don't believe it. What on earth have I done wrong there? Oh, I see. Right. No, okay. Okay, right. What I was just thinking about then was how... I was trying to think about what is the solution to this puzzle. Because the solution must involve me being able to map all of these colours uniquely into the grid. And I didn't see, just looking at this, I mean, we've just got white squares here. We've got no Sudoku, at least that I can immediately see, that's going to be disambiguated in this column. With the exception, I suppose, and this I think is what must be going on, of these 2 digits. Now these 2 digits, I mean, we could make this, at this point, this could either be red or purple. Now, if this was purple, I can see that that would disambiguate these digits. So it would go purple, purple, purple. This would be green, and everything then, I have a feeling, would uniquely solve. Whereas if this is red, I do not see how this puzzle can be solved uniquely, because I don't think this can ever be disambiguated. So I think what we're going to have to somehow show now is that this square, by probably the maths of this equation, has to be purple for there to be a unique solution. So if you were speed solving this, good luck to you. But I think you could perhaps assume this was purple now. I'm not sure about that, but that's what's occurring to me, and well, I'm quite relieved, because that means that I still have an opportunity to solve the puzzle. Because all I've got to do is to solve this equation, and prove why this digit has to be, well, if that has to be purple, purple is the 1 digit, isn't it? Purple is the 1 digit. So I want that to be the 1 digit, so I want that to be a 2. Why does this have to be a 2? If that's a 2, or maybe I should be trying to do it the other way around and trying to make it equal to 1. I don't really understand what I'm meant to do here. So what exactly am I saying? I'm saying that 5 point something that can't be as high as 6, because that would, if it's as high as 6, this equation breaks. 5 point something multiplied by 1 point something added to a number that's an integer is exactly equal to 8 point something that could this time be as high as 9. But these... I don't see how we can do that. I don't see how we can do that and get an integer value here. Is it something to do with the sort of decimal parts of all of these pieces? So the decimal part of the 8 number, this is so complicated, is equal to the decimal part of the 2 1 numbers, and the 5 number. But the 5 number has a decimal part that includes the 2 1 numbers again. So the decimal part of the 8 number is 2 times the decimal part of the green and 2 times the decimal part of the yellow. And the decimal part of the 5 includes 1 of yellow's decimal part and 1 of green's decimal part. So the green decimal part is getting squared within that. And then we've got this going on as well. So what's this saying? This is saying that 2 times the decimal part of the yellow. Well, yeah, it's saying that to equate the left-hand side and the right-hand side of this equation, the decimal part of green is double the decimal part of yellow, because the integers are just going to cancel, have no decimal parts. So for this equation to be valid, if this was 1.1, this would have to be a 0.2 number, wouldn't it? Because we're multiplying 2 by 1.1, so this is 2.2, so this has to be 1.2. So the decimal part of this is, the last digit of green is even. When I say the last digit, I mean the last digit of its decimal part. So the last digit of this one's decimal part is even, and that's being multiplied by, but if that's even, we know that that's got an even decimal part, because it's 2 times the yellow's decimal final digit and 2 times green's decimal final part. So it works, because this is always going to give even, whether the 5 number is odd or even. It's going to revert back to being even once it gets multiplied by the even nature of this. And even I'm using in a very loose way there. I'm using it to describe the last decimal digit of this green clue. Oh, I see. Oh, I do see. I do see. Right. Right. Okay. Here's an idea. Here is an idea for you. So, isn't it true to say that I have two equations with two unknowns here and here? With the unknowns being the yellow and the green digit. Now you may look at this and say that this equation doesn't have, it has lots of unknowns in it. We don't know what blue is, we don't know what orange is, but we do in a way. We do in terms of the yellow and the green digit, because we know that blue is an expression that is linked in terms of what its unknowns are. The value of blue, the only thing we don't know about its value is the value of the green 1 digit and the green yellow digit, and the only thing we don't know about the value of 8, well, is again it's the yellow, the green and the blue, which we've just said is an expression involving the yellow and the green. So this could be rewritten, I think, as a great big long expression involving yellow and green, and an unknown here, which is an integer, and this that's very straightforward, relatively, expression of yellow and green. So I've got two equations and two unknowns involving yellow and green. Okay, I'm fairly, I don't think I can I do this in my head? I always try. Let me just think about this for a second. I could probably express this one in my head. So 8 is equal to yellow, green. Oh no, it gets horrible very quickly because I don't know what that one is. Okay, so 8 is equal to this digit here is equal to 2 lots of yellow, because there is a yellow within blue. So it's 2 yellow, 2 lots of green, because there is a green within blue. And in terms of integers, we've got a 1, and within the 5 we've got 2 integers. We've got a 2 and a 1. Right, so the value of 8 is 2 yellow plus 2 green plus 4. Two yellow plus 2 green plus 4. But the value of this side of the equation see, the thing is, that's horrible from an algebraic perspective, because that's got to be, I've got to rewrite blue in terms of yellow and green, and it's 3 plus yellow plus green. 3 plus yellow plus green is that one, and we're multiplying that by green. Oh, goodness me. So 3 plus yellow plus green times green is 3 green plus yellow green plus green squared. And all of that's got to be added to an unknown number, well, a number that's 1 or 2. And then I've got to somehow... I don't know if I can do this in my head. This is feeling very complicated. I don't like the existence of green squared in this one. Yeah, okay. I think this is going to be a quadratic equation. And it may even be worse than that. I'm not good enough at maths in my head to know that when I substitute in either green or yellow into this equation, which has got squares in it, what I'm getting out the other end. How on earth am I going to do this in a video? I don't know, actually. I think I'm going to need to write this down. I could do it on paper, or I could I don't think I can really... Can I use Notepad to do this? Can I do it with Notepad somehow? I can try and do it with Notepad. So what are we saying? What are we saying here? We're saying... Let's do the top equation first. 1 plus green is equal to 2 times yellow. So that's actually fairly straightforward, isn't it? Okay, so what I could do there is I could say that green is equal to 2y minus 1. And then I'll substitute green into the bottom equation, which I've now got to rewrite. And in the bottom equation, I've got a number that's 1 or 2, I don't know which. That doesn't mean half, that means 1 or 2. Added on to green, multiplied by green multiplied by the 5 number. Now the 5 number, the 5 number was equal to 3 integer y's plus green plus yellow. So that's the left hand side of that equation, and that's equal to 4 plus 2 green plus 2y. We worked that out before. So the left hand side of the equation becomes 1 or 2 plus, now this was where it got complicated, 3g plus g squared. I don't even know how to do that in terms of, how do I do a g squared? Is that going to be that button? G squared. Okay, plus gy, and that's equal to 4 plus 2g plus 2y. But now this is going to get horrific, isn't it? Because I've got to substitute into that my equation for g at the top. G equals 2y minus 1. Oh no, this is horrific. I'm not sure I'm doing this right at all, actually. There must be a better way of doing this than this, is there not? It did say, someone did say algebra was involved. I mean, but we're now going into the realms of absurdity, aren't we? Let's just try this. Okay, so 3 times g, that's going to be 6y minus 3, I think, for the 3g expression. And we're adding to that g squared. Now, g is 2y minus 1, so that's 4y squared. 2y times 2y minus 1 times, well, I know there's a plus 1 element. When I multiply the 2 minus 1s together, they must equal plus 1. I remember that from school. And then I'm going to have minus 2y twice, so that's minus 4y. But then I've got to add to that g times y again. So I'm going to get another squared term from this, because I'm going to have, I could get this so badly wrong as well. So 2y minus 1, so 2y squared, I think, 2y squared. And then I've got minus, what? I want to say minus y. I hope that's right. And that's all equal to 4 plus 2g, so that's 4y minus 2 plus 2y. Chameleon, you are the essence of evil. If this is what you're meant to do to solve this puzzle. I've been reduced to trying to solve a massive equation on the screen. Okay, Right, let's bundle up the terms then. What have we got in terms of y squared? It looks like I've got 6y. 6y squared. What have we got in terms of y itself without being squared? We've got 6y minus 4, so we're down to 2y. Minus y, so we're at y. Oh no, on the other side. So I've got minus 5y. So this has got to change. Minus 5y. And then from an integer perspective, we've obviously got the 1 or the 2 to be added into all this nonsense. I've got minus 3. Okay, I guess I'm on minus 7. Golly, gosh, this is very confusing. I'm terrified I'm going to miss a digit here. I've got minus 3, minus 2. Hang on, I've now done it twice and got different answers both times. I'm going to separate all these out so I can. So they look more normally formatted to me. Has that got space? Right. Okay. So I've got minus 3, minus 2, minus 6, minus 4. That doesn't feel okay. It could be right. Minus 4 equals 0. Okay. But I don't know what this other digit is. So if this digit was a plus 1, then this equation would have minus 3 at the end. If it's plus 2, it's got minus 2 at the end. Because now I'm presumably going to have to do my quadratic formula thingy. Now, I do remember there was a way of solving quadratic formulas. You had to sort of multiply the outsides together, so that would be 24. No, it wouldn't be 24 because it depends whether... No, it's not 24 because this number's wrong. Well, it's wrong. It's because it's... If this became minus 3, it'd be 18. And then I need two numbers. Don't I have to add them up to minus 5 or something? It was something like... Maybe this is total utter nonsense. I really apologise if any mathematicians are watching this and they're thinking, this guy is an absolute numpty. But I thought what you had to do when you tried to factorise this without using the formula was you added them up to minus 5 and you multiplied them together to the outside ones. But that almost feels like I've definitely got this wrong. Because I don't think... If this was minus... Well, if this was 2, it might work, because then I'd be multiplying to minus 12 and adding to minus 5. That still feels impossible. I think I've made a mistake here. I'm sorry. Let's try the formula then. Now the formula, I'm going to have to remember this correctly. Minus b plus or minus the square root of b squared minus 4ac over 2a. Sort of trips off the tongue. I mean, how long is it since I've thought about that? Minus b, that's 5. Okay, plus or minus the square root. I don't have a way of showing that. I'll put it all in brackets. The square root of b squared, that's 25, minus 4 times a, that's 24 already, times c, minus, but c is minus, so this becomes plus overall. Sorry. So it's plus, but now it depends what this is. 4ac, so it's 24. 4a and c is either 3. So this number is 3 or 2. And that's all square rooted. I don't know how to put square root like that. That gets square rooted and divided by 2. The whole thing that's divided by 2a. Let's be plus or square root Or is it the thing inside the square root that's divided by 2a? I can't remember. Minus b plus or minus the square root. I used to be able to prove why this equation was correct and things like that back in the day when I was actually fairly, well, not competent at maths, but I knew some maths. Minus b plus or minus the square root. I'm trying to visualize the formula in my head. The whole thing's over 2a. Squared minus 4ac over 2a. Oh, no, I'm not sure now. I don't think the minus b lived on its own as a sort of separate component of the equation, and then you did the other things separately. That doesn't feel right. Oh, goodness, the other thing is I've got to make sure that whatever I get from this is a number that's just over 1. Right, I mean, I need a calculator to do this. What's 3 times 24? That's 72. So 72 or 48. I've got to square root silly numbers. These are not integers. 72 plus 25 is 97. So I'm either square rooting 97 or I'm square rooting 73, 48 plus 25. Right, I need a calculator. Is there a calculator in? Calculator. Right, I have got a calculator. Here we go. Sorry if you can't see this on the screen. I was not expecting to have to find unusual apps to solve this. So, what have we got now? So we've got... Well, let's work out the square root thing. So we've got 25. Oh no, hang on. I can do that part in my head. So I want to square root 97. 97 square root. Okay. All right, that's good. So that this is why Chameleon said the answer must be real, isn't it? Or am I wrong about that? Maybe that's wrong. Yeah. No, because this is plus or minus, isn't it? Minus b. Oh no, hang on. Which part of the equation is plus or minus? Minus b plus or minus the square root b squared minus 4ac all over 2a. If it is all over 2a. Minus b plus or minus. No, okay, maybe I'm wrong about that. I think because if I was trying to square root a negative number, I would have had bigger problems. So maybe this is fine. So, right, so what do we find? We found the square root of 97. And then I think I need a root that is just over 1. So I don't want to deduct this from 5. I must be adding this to 5. Oh, I can't find the add button. Add 5. Divide by 2a, which is 12. That does look like I might get a number like 1. I got a number like 1. 1.23. That's not a very nice number. 1.23740 is a possible answer to the equation, but it's not the only answer. So hang on, let's go down here. So one answer is 1.23740. I don't know how many decimal places I'm meant to use here. And that's the value of y, isn't it? So the value, which is yellow, so the value of green is then 2 times this minus 1. So times that by 2 and minus 1. 1.4748. 1.4748. Now, was this the version that I thought was going to fail or not? So in this version, what I've done is I've included in here, I was 3 times, I did 97 square rooted. So in this version, I've used 1 in this position. So I only deducted 1 from the C digit. So is this the version that fails or succeeds? That's going to give me a red. Now, this is the version that shouldn't be correct. That's weird, isn't it? So for some reason, this fails. Let me just go back. What was the answer? So green was 1.4. The two of them together add up to 1.7, a bit more than 1.7. Is that the problem? So if in that situation, this is 5.7. Ah, that's it. Yeah, that's it. Right. Got it. The reason this fails is beautiful. And the fascinating thing about this, I mean, we've got to come back and talk about this, because this is ludicrous. It's absolutely ludicrous. So I think I understand what Chameleon has somehow done here. The roots of this equation, or these equations, I don't even know what the right way to describe it as. If you use 1 here, they cause they cause this to be 5.7 something, which is going in here. But they also, these two digits, when added together again down here, give you another. The decimal component is 0.7 again. And when you add this 0.7 to this 0.7, you get 1.4. So you get an extra units digit, which you can't have in this equation. Because if we just add them all up, imagine they're all integers. 1 plus 1 plus 1 plus 5 is 8. This cannot be greater than 9. But it would be, because if this is 0.7 adding to this 0.7, that's giving us another 1.4 to add on from the decimal components. And we can't add 1.4 onto 8 because we're getting far too high. We're getting beyond 9, which is one of the limits in the puzzle. So I think what might happen, and if it does, chapeau, that is unbelievable. Because if this is 2, so that the decimal component of these two when added together is less than half is what we need it to be. So that when we add it again here, overall this digit stays either at 9 or just below 9. That is, I think, how the puzzle actually disambiguates to solve. Right. This is very exciting for me, and I'm sorry if people don't find absolute joy in this sort of thing like I do, but this is right. So I need the calculator because what I need to do now is to rework this. If this was 48 plus 25, which is 73, so 73 square rooted, and then I'm adding that to 5 because I don't want a negative answer, and I'm dividing that by 2a, which is 12, and I'm getting, I must have done, I think I added, it looks like I added 12, I didn't mean to do that. I wanted to divide by 12 equals 1.1286. I mean, it's a horrible answer. So this is the answer for, which one is this? This is this was yellow, wasn't it? So yellow is equal to 1.128666. Okay, which means that green is equal to 2 times this minus 1. So let's do that. Minus 1. 1.25. 1.25733, a lot. But the wonderful thing about this is I can see that when I add these two together, I definitely don't breach the 0.5 decimal part, which would have worried me. Because in effect, now we can think about, if we go down to, so let's remember this. In fact, let's round them up. So y would be 1.13 and g would be 1.26. Okay, now so we know that this has in it 1.13, so 1.13 plus 0.26 is 0.39, and this gets another 0.39 because this and this have to be included, but 0.39 plus 0.39 is 0.78, and that means that this is 8.78 roughly, with all those decimal places, but it's still below 9. Which it couldn't be if we did it the other way around. So I think this is the solution, and it proves that this digit is in fact a 2. This is breathtaking. It's absolutely breathtaking. So this is 1, whoops, this is 1, this is 2. This is now 1, and the great thing about that, of course, is that it's purple, which is going to tell us that this now is a 1, and is purple, which means that this is now green. And I don't know how to do this. I don't know how to put this into the software. That's a 2 by Sudoku. Now, if this doesn't disambiguate at the top, no, it does, because the blue's got to go here now. It's going to work, which means that this digit is now green, which is a 1. Oh, it's not really a 1, but you know what I mean. That's green and is a 1. That's blue and is a 5, and that is something that I should know, and that's a 1. It's a purple 1, and that I think, purple 1 with a big digit. That is the solution to the puzzle, I think. Where, and this is the tricky thing. Let's go back to where's my notes again. Where, we need to work these out. I need to work all of these out. Because I've got yellow and green, worked out, but I haven't worked out the value of blue. So blue is equal to 3 plus these numbers. So I don't know what's a reasonable number of decimal places to work with here, but okay, let's add to this 1.128666 plus 3. So 5.385. Well, let's call it 5.386. 5.386. And so orange is equal to that number that we just thought of plus these two again. So we've got to add to that 1.128666 plus 1.25733 plus 1 as well, actually. Let's make sure we don't miss off the 1. So it's basically 8772 is the answer. 8.8772. Let's just check that. No, I've got that wrong. 8.772. So I think that those are, if I could put them into the puzzle, that's what I would put into the puzzle, but I don't know how to. So what's going to happen if I click no, well, it says it doesn't look right, but presumably that's because it can't understand. I mean, this must be correct. It must be correct, because how could it not be correct? it's too impossible to imagine that disambiguation wasn't by design. The fact that when you did it the wrong way, the numbers flipped up just slightly too high in their decimal positions, such that the equations fail. It's too unbelievable. This is right. I mean, I might have made some small errors with the arithmetic, but this is effectively. I don't know quite what we're going to do about that in terms of suggesting to people how to check that whether they've got the answer. But let's just call this for what it is, which is, it is the meanest mini I've ever seen. That's definitely for true. I mean, it's absurd. It's absurd, but it's also sort of wonderful that somebody with almost no mathematical knowledge remaining can actually solve it with a little bit of memory about quadratic equations from school days and a calculator. That's all we needed. I don't know what to say. I mean, we've done a couple of videos for Numberphile where we talked about mathematical puzzles, and well, I wish this one had been at our disposal, because no one could claim this wasn't mathematical. I don't know where would you put this in terms of sort of school level mathematics. I mean, frankly, if this was set at some fairly serious level for young people to achieve some sort of distinction in exams, you wouldn't say they had it easy. That's not easy. It wasn't easy. It was absolutely magnificent. And that final piece there, how have you set this though? Let's just give that a moment's thought before we conclude. So Chameleon has somehow, I mean, it's absolutely brilliant to think about it. It's come up with a form of equations that can be expressed in a Sudoku, where the ambiguity is in the perfect position to disambiguate the rest of the puzzle. I have not got a clue how you came up with this. Isn't it wonderful though? These minds that we're doing battle with at the moment, they are absolutely first class. That is just sensational. That is sensational, and I apologise to everybody out there who is a mathematician who has been watching this video shouting at the screen at me. Mea culpa. But I had a lot of fun, and I am actually very relieved to have solved it. We'll be back later with another edition of Cracking the Cryptic.